Hello everyone and welcome to day 2 of Unit 8, which is on special right triangles. This is the first part of special right triangles, and we are going over a kind of right triangle called a 45, 45, 90 right triangle. So what that means is we have a triangle with two 45-degree angles and one 90-degree angle in the corner. That's the kind of triangles we're talking about. So first we're going to go over how to rationalize denominators. So when we are dealing with square roots, we do not want radicals in the denominator. So we need to rationalize these fractions by getting rid of the rational in the bottom, or the radical in the bottom. So let's look at number 1. To get rid of that radical at the bottom, that's a square root of 4. First thing I could do is simplify that. Square root of 4 is just 2. So I have 5 over 2. For the next one, I have 4 over the square root of 2. Now, square root of 2 does not simplify. So I have to get rid of that radical by multiplying it by the square root of 2 on the top and the bottom. If I multiply by the square root of 2 on the top and the bottom of my fraction, I'm not changing the value. So I know I can do that because square root of 2 over square root of 2 is just 1. So when I multiply by 1, doesn't change anything. When I multiply straight across, I end up with 4 square root of 2 over square root of 2 times square root of 2 is just 2. Now I'm almost done. I just need to simplify this fraction. I have 4 root 2 over 2. I can reduce that to just 2 root 2 because 4 divided by 2 is 2. Okay, number 3. So same thing, I just need to multiply by the square root of 3 on the top and the bottom to get rid of that square root 3 at the bottom. So, multiply across, I get 3 square root of 3. Square root of 3 times the square root of 3 is 3. Again, I can reduce 3 divided by 3 is just 1, so that'll be 1 root 3, but we don't normally write that 1, so it's just root 3. And last one, I just need to multiply again by square root of 3 on the top and the bottom. When I multiply that, I end up with 3 square root of 2 times square root of 3 all at the top. Square root of 3 times square root of 3 is just 3 once again. Now when I have two radicals next to each other like that, I can put them all under the same square root sign. So that's just 2 times 3 over 3. And again, those 3's will cancel, so I'll go ahead and or not cancel, they reduce to 1, so we don't necessarily need to write them anymore. So I'll just simplify my radical by doing 2 times 3, and I end up with square root of 6. Okay, for number 1 and 2, on these two examples, I need to write my sides and angles from shortest to longest. So let's start with number 1. So remember that the shortest side is going to be opposite the smallest angle, but on this one, I only have 2 angles, so I need to figure out the third one. I have a 60-degree angle, I have a 90-degree angle, and I need to know this one. So remember in a triangle, all of the 3 angles add up to 180, so I'm going to go ahead and do that. 60 plus 90 plus my missing angle has to equal 180. Simplify this. 60 plus 90 is 150 plus x is 180. You subtract that 150 over, and you get x is equal to 30. So my missing angle here is 30 degrees. So let's go ahead and start with my angles from smallest to largest. My smallest angle is the 30-degree angle, which is angle P at 30 degrees. My next biggest angle is angle M, and it is 60 degrees. And my largest angle is angle N, and that's 90 degrees. So remember that my smallest side is going to be across from my smallest angle. Now we know my smallest angle is angle P, it's 30 degrees, so my smallest side is going to be opposite that angle, and that would be side MN. So MN is the smallest side. My medium angle is the 60-degree angle, and the side opposite that one is side NP. So NP is the next one. And my longest side is opposite my 90, or my largest angle, which is side MP. Okay, with number 2, we're not given any angle lengths, but I do have a lot of side lengths. So I'm going to use those to figure out my smallest angles. First, I'll just start off by listing my sides from smallest to largest. My smallest side is side DB, or BD, however you want to write it. It's 6 inches. My next longest side is 8 inches, and that's side CD. And then my longest side is CB at 10 inches. So to find our angles from smallest to largest, I'm going to find my smallest side and go across and look at the opposite angle. So my smallest side is side DB. My opposite angle here is angle C. So angle C is my smallest angle. My next smallest angle will be across from the medium side, which is side B, or side CD. So that's angle B. So angle B is my next largest angle. And my longest side, CB, is opposite from my largest angle, which is angle D. So in a right triangle, the largest angle or right angle, because the largest angle is always going to be the right angle, will always be opposite the largest side or the longest side, or we call it the hypotenuse. And the smallest angle will always be opposite from the smallest side. So now let's move on to some specific rules for a 45, 45, 90 triangle. A couple rules we want to remind you of: that if we're getting larger, we're going to be multiplying. And if we're getting smaller, we will divide. Okay, now I want to draw your attention to this triangle right here. This is our special 45, 45, 90 degree triangle. Now, what I want you to notice is that since we have two equal angles, we also have two equal sides, and they would be these two legs of our triangle. So these are congruent, and we label them both as x. Notice they both have an x here. X is going to be the same number. They're going to be equal. Now the hypotenuse, or the side across from my 90, my longest side right here, in a 45, 45, 90 degree triangle, it will always follow this pattern. It's going to be x times the square root of 2, always. So the leg length times square root of 2. So let's fill out this chart. When we have a leg and I want a leg, they're just equal. When I have a leg and I want the hypotenuse, I need to multiply, because we're getting bigger. When we're getting larger, we multiply. We're going to multiply by the square root of 2. And when I have the hypotenuse and I want the leg, I'm getting smaller, I need to divide by the square root of 2. Okay, let's do some examples. So we are given a leg length. I need to find the hypotenuse. So I have a leg length. I need the hypotenuse. We are going to be getting bigger because the hypotenuse is the largest side, so we're getting larger. And when we have a leg and we need the hypotenuse, we need to multiply by the square root of 2. So let's do that. Our leg length in this case is 2, so I'm going to multiply 2 times the square root of 2, which is just 2 root 2. Okay, let's do number 2. In this case, our leg is this side. It's 11. We need our hypotenuse, which is y. So we're going to, again, multiply by square root of 2. So 11 times square root of 2, which is 11 root 2. Okay, for 3 and 4, we need to find the leg given the hypotenuse. So now we're going the other way. On number 3, we have, again, the hypotenuse. I'm going to abbreviate. We need the leg. We are going to be getting smaller. The hypotenuse is the longest side, so we need to get smaller to get the leg. So which means we are dividing by square root of 2. So I'm going to take my hypotenuse, which is 7 root 2, and I'm going to divide it by root 2. So I'm going to write that as a fraction. So that's 7 root 2 over root 2. Now these root 2's will reduce themselves out, and we'll just be left with 7. Okay, number 4, same thing. My hypotenuse is 16. We need my leg, which is y, so I need to divide by square root of 2. Again, I'm going to write that as a fraction, so 16 over square root of 2. Now this is going back to our first couple examples. I have a radical at the bottom. I cannot have a radical at the bottom. So I need to simplify this so there is no radical at the bottom. So to do that, I'm going to multiply the top and the bottom by my radical, which is square root of 2. Now I'm going to multiply that across. 16 times square root of 2 is just 16 root 2. Root 2 times root 2 is 2. And the last step is to reduce. 16 root 2 divided by 2. 16 and 2 divide to 8. So that will just be 8 root 2. Okay, on 5 and 6, they do not tell us which part we have or what we need. So we need to figure that out for ourselves. So let's look at where our variable is. For number 5, our variable is right here, and that is talking about the hypotenuse, and we can check because it's across from my 90-degree angle, which will always be the longest side. So we are going to be getting bigger because our hypotenuse is the longest side, and we are given a leg length right here. It's 12. So to find the hypotenuse given a leg, I need to multiply by square root of 2. So 12 times square root of 2 is just 12 root 2. Okay, number 6, same kind of concept here. Let's figure out what our variable is. Our variable here is z. It's across from the 90 again, so we are getting bigger. We have 2 leg lengths in this case, but we only need to use 1. So we're going to just take 6 and multiply it by square root of 2. And we get 6 root 2. Okay, for number 7, we have 2 variables with this one. So let's look at what we have first. We do have a leg length. We have this leg here. It's 5, which means my other leg is going to be equal to that, which means x is equal to 5 because the legs are equal to each other. Now to find my hypotenuse or my longest side, I needed to multiply that by square root of 2. So I'm going to take 5 and multiply it by root 2. And that's just 5 square root 2. On number 8, I have 2 variables again. These 2 variables are here, and they are talking about my legs, which are the same. So how do I find a leg? When given the hypotenuse, which is 6, I need to take 6 and divide it by square root of 2 to get smaller. So I'm going to write that as a fraction again. So 6 over square root of 2. I need to rationalize this fraction by getting rid of the radical at the bottom. So I'm going to multiply by the square root of 2 on the top and the bottom. When I do that, I'm going to end up with 6 root 2 over 2. 6 and 2 reduce to 3 root 2. So that's the length of one of my legs. We could call it x, we could call it y, but it doesn't really matter because x and y are equal to each other anyway because they're both the legs of a 45 degree triangle. Okay, for number 9, we need to find the length of a diagonal for a square whose perimeter is 28 inches. So first thing, let's draw a square. Okay, I got my square here, so we need to find the length of the diagonal, which is right there. We know that the perimeter is 28 inches. The perimeter is what you get when you add up all the sides of our square, and our square has 4 congruent sides. So to find the length of just one side, I can divide that by 4 because they're all the same. So 28 divided by 4 is 7, which means all my side lengths are 7. So to find my diagonal, I'm going to use this triangle here made with my 3 sides. 2 of the sides of the square, and then of course the diagonal that I need to find. This is a 45, 90 triangle. The 90 degree angle of course is here, and these are the 2 45s, which means that 7 and 7 are my 2 legs. So when we have a leg and we need the hypotenuse, we just multiply the leg by square root of 2. So 7 times root 2 is 7 root 2, which is the length of my diagonal. Now, if we wanted to actually put this in terms of inches, because that really doesn't tell me much about the length of the side, 7 root 2 doesn't really make much sense. So I'm going to put it in terms of inches, and I'm going to round to the nearest decimal place. So when you put this into your calculator, you're going to get a weird long decimal because square root of 2 is an irrational radical. So it's going to be a long number, so we do need to round. You end up with 9.899, but we need to round that up to the first decimal place, so it'll be 9.9 inches. Okay, for number 10, we need to find the perimeter of a square whose diagonal is 6 feet. So this is my diagonal. We know it is 6 feet, and I need to find the length of one side to find the length of all the 4 sides so that I can find the perimeter. So we have the hypotenuse. We need the leg. So we need to divide 6 by square root of 2. Again, I'm going to write this as a fraction, so 6 over square root of 2. Rationalize it by multiplying top and bottom by the square root of 2. And you get 6 root 2 over 2. Last step is to reduce 6 root 2 divided by 2 is 3 root 2. So that is the length of one of my sides on my square, is 3 root 2. Now, I need to find the perimeter, which means I need to add up all the sides, and luckily this is a square, so they are all the same length. So I'm going to add them all together, so 3 root 2 plus 3 root 2 plus 3 root 2 plus 3 root 2. And when I add those all up, you actually will just be adding up these whole numbers. The root 2 will be kind of treated like a variable when we're adding. So 3 root 2 plus 3 root 2 blah 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 will be 12 root 2. And again, we can simplify that into normal number terms. So I'm going to go ahead and do that in my calculator. And I end up with 16, actually about 17, because it's 16.97. So about 17 inches. So that is it for day 2. Leave a like down below, and we'll see you for day 3.